Okay, so somebody asked about the stop signs question from number 21. I know a lot of people are having trouble with 21 material. It happens every year. It's just a rough chapter. So I'm going to go over that question. It's number 26 in the yellow book, 25, I believe, in the blue book. So highway safety engineers test new road signs hoping that increased reflectivity will make them more visible to drivers. Volunteers drive through a test course with several of the new and old style signs and rate which kind shows up the best. So, so we'll go through these a little bit at a time. We'll talk about it. So whether this is a one-tailed or two-tailed test. First off, the way that it's worded and what they tell the drivers, determining which kind is best, kind of makes it sound like it could go either way, a two-tailed test. However, since what they really want to know is whether those increased reflectivities make them more visible, that would be our alternative, a two-tailed, because they really only care if it's better. And I'm not going to write that whole explanation out. And then part B and C go into type 1 and type 2 errors. Before I get into that, I want to write kind of in words off to the side here in my little, whatever this is. What the hypotheses are. So the null hypothesis is that there's no difference. And I'm just going to go with words. I'm not going to bother with those symbolically because we don't have any numbers to go with and all that kind of stuff. The alternative hypothesis would be that the new ones are better. Okay, so type 1 error in context. I didn't leave myself a lot of space, so I'm not going to write this whole thing out. A type 1 error is when the null hypothesis is true. So null is true, but because of our data, we reject it. Now, that's a good explanation of what the null hypothesis, what a type 1 error is. It's not in context. And remember that anytime on any part of any test, you want to have your answers in context, even if it doesn't say it. Always make sure that the context is there. And don't write in context, just say what the context is. So in this case, the null is true, but we reject it. So instead of saying the null is true, we're going to say it's true that there's no difference between the two signs, but based on our data, we reject it and believe that the new signs are better. So in which case, what would happen is, and this isn't part of the question, but whatever. What would happen is that the state or whoever I think the state is in charge of highway signs, I don't know, would pay for all these new signs when they really don't make a difference. So, I was going to repeat myself, but you can go back in the video. So then a type 2 error, the null is false, but we fail to reject it. Remember, with both the type 1 and type 2 errors, we're not making an error because we actually made a mistake. We're making an error because our data showed us one thing, but what's happening in reality is not the case. So a type 2 error would be that the null is false, that there actually is a difference in the signs, that the new signs actually are better, but our data didn't show that, and so we don't purchase the new signs. So in this case, a type 2 error, I don't think I said that very well again. So, sorry, rambling. So a type 2 error would be that the new signs are actually better, but our data didn't show that, and so we failed to reject the null hypothesis. So in that case, they could have made the roads probably safer, and the signs would be better and more reflective, but they failed to reject that null and did not purchase new signs. So that's the type 2 error. Power of a test, and this they want in context as well, I just didn't write that. The power of a test is the probability that it will correctly reject the null hypothesis. And that's just going to take me a while to write. Okay, so in that sentence I just wrote, the probability that a test will correctly reject a false null hypothesis. The fact that I put false there is redundant, but it doesn't hurt it. So because if we correctly reject a null hypothesis, then by definition it's a false null hypothesis. In this context, this is the probability that we would actually see that there is a difference in the new signs, so that this test would actually show that the new signs were better. So that's what is meant by the power of this particular test, the probability that it will show us that the new signs are better. Assuming that they actually are better. Part E, if I use a 1% alpha instead of 5% or 0.01 instead of 0.05, remember alpha is the level that we set for the threshold that we set for our p-value. So if I have on the lower end here, I've got 0, I've got a 1% alpha, and I've got a 5% alpha. And I'm going to write those not in percentages, just because that's not how our p-values generally come out. So 0.05, 0.01. Remember, alpha is also called the significance level, so you will hear that both ways. So if I set an alpha of 0.05, if my p-value falls anywhere in here, then I'm going to reject the null hypothesis. If I change that and I make that space smaller, that's a weird little thing. Try that again. If I make that space smaller, the probability that I'm going to reject that null hypothesis is lower. And remember, alpha is the probability that you will reject the null hypothesis. And when we think about the power of a test, we're looking at the probability that it will correctly reject a null hypothesis. If we make it less likely that we'll reject a null hypothesis, we are actually decreasing the power. Now, this always throws people off because when we lower when we lower alpha, we're also lowering the probability of a type 1 error. When we set alpha, that is the probability of making a type 1 error. Pardon me. So when you're thinking about power and the type 1 error, that's kind of a balance that has to be worked out, because as you increase alpha to increase the power, you're also increasing the probability of a type 1 error. But if we decrease alpha, then we are decreasing the power of our test. And finally, if they wanted to use 50 drivers, but time and budget required they had to cut back to 20, how does that affect the power? That's also going to decrease the power. One of the things that we know is that, and this is one of the things we just kind of focused in on with power of a test. If we want to increase the power of a test, we increase alpha and we increase the sample size. If we increase the sample size in general, that's going to make our test more powerful. But if we don't have any control over that, then we have to think about what we want to do with alpha and how we want to balance that with the probability of a type 1 error. So hopefully that clears up some stuff from chapter 21. Again, let me know if you guys have any more questions on any of the stuff. It doesn't have to be from the practice test, just anything that might help you prepare for the test. Have a good one.